Hello everyone, good morning. Am I audible? Yeah, right. Okay, so let's begin with the session. So before that, before starting with the session, I have a few announcements here, which I shall try to do it now. Okay, so from today's session, right? So there are three batches which I'm just combining and doing it. Okay, it's 61, 62, and 63 batch. Okay, so there are three Java batches which I have combined and I'm trying to do it in a single session. Okay, a few topics 61 and 62 is Keshev's batch. Okay, and 63 is mine. Okay, so I'm trying to combine both the batches because they are almost in the same flow. Okay, so a few topics might be repeated for 61 and 62 because it's Keshev's batch. Mine, no issue, okay, because I'm going with the flow. So 61 and 62, a few topics might be repeated for you all, but don't worry, it's just going to be revision session for you all. Okay, so probably two, three topics. Okay, that's it. Apart from that, I know what sir has done. I'll continue with that. Okay, so this was the first announcement here. Okay, so that is 61, 62, 63. Will start attending my batch on daily basis from 9:30 a.m. Right? From 9:30 you'll have my okay. From 9:30 you'll have my Java session. Right? Perfect. And then the next part here is we had mock. Okay. I'm not sure about 61 and 62, but 63 batch we had mock. Okay, I'm not sure of how many of you have given and how what is the ratings you have got because I have not spoken to Manish yet. Okay, the person who took mock. Okay, so let me just cross check and I'll update you regarding it. Okay, so done. We are done with this basic things which I had to tell now. Okay, so today's topic which we are going to discuss is something called as upcasting. Okay, and downcasting. Okay, the topic which we are going to discuss today is upcasting and downcasting. This is one of the most important and the trickiest concept we have in entire Java. Trust me here, many of you know will feel this is the difficult topic which we have in Java. But the one more thing over here is okay, this is the widely used topic in Java. Okay, it's tricky, that's the reason it is widely used in Java. But if you understand today's session carefully, probably the entire Java until I'm done with Java here, it's going to be very easy here. Clear? So make sure we'll try to do it in a beautiful way here. Okay, I just want your complete concentration. For the people who know it already, just have patience level in understanding. Who do not know it, concentrate properly. Because I'm telling you again and again, this is one of the most important topics in entire Java. Okay, so what is upcasting and downcasting? We will talk about it. Before that here, we got into typecasting in the last session, I believe, right? We got into something called as typecasting. What was typecasting? Converting one type of data into another type of data. So there were two types, primitive, non-primitive. Primitive was widening and narrowing, which we have completed in the last session. So in today's session, we are jumping into non-primitive casting. Okay, so that can also be called as derived casting or class type casting. So that is further divided into upcasting and downcasting. So majorly we are concerned with what is upcasting and downcasting in today's session. Okay, so primitive, narrowing and widening, non-primitive, upcasting and downcasting. So we are supposed to understand what is upcasting and downcasting in today's session. So we have a couple of points over here. Okay, this is what it is all about, upcasting and downcasting. Okay, but let me try to give couple of examples here. That is when you will be able to understand properly. Okay, now guys, imagine. Okay, so closely observe guys. Okay, you need to have the patience level completely now. Okay, so in order to understand this particular topic. Okay, imagine there is a couple of classes. Okay, I am having a couple of classes here. Okay, imagine this is one class and this is another class. Okay, so now here this class name is father and this class name is son, and father has a property x equals to 10 and sun has a property y equals to 20 here. This is all about the entire process here. Got it? So we have a couple of classes here, that is father class and son class. Now I need to achieve is a relationship between them here. Okay, so now how do we achieve easy relationship between them? Extends keyword, right? So, we also make use of extends keyword in order to achieve inheritance or easy relationship. Correct. Perfect, right? So this is what we are supposed to understand over here. Okay. So I hope you all got the basic idea here, right? Perfect. Now we are supposed to understand something called as upcasting. Okay, what is upcasting? I will tell you. Guys, there are two classes. Father is the superclass, son is the subclass because they have easy relationship between them, that is extends keyword. Now, what do you mean by upcasting? Upcasting means we are creating an object of subclass. Okay, see, we are creating an object of subclass and storing its address into a reference which is of type superclass here. Okay, so this is nothing but upcasting. I repeat, guys, you need to have patience level in order to understand this particular topic. Okay, see, we are creating an object of subclass and storing its address into a reference f which is of type superclass. So this is called as upcasting. Superclass reference subclass object, that is called as upcasting, right? And then second point, okay, upcasting is always done implicitly. Okay, so from the subclass I am going to the superclass here. So upcasting is always done implicitly, and without is a relationship I cannot upcast it. Okay, without is a relationship, that is without inheritance I cannot achieve upcasting, and upcasting is always done implicitly. Clear? Perfect. Done. Now, with this reference f here, f is of type father. Okay, f is of type father here. So with the help of f, I can access only the superclass properties. So I can access only x here, whereas y we cannot access here. Got the clarity here? We can access only x here, but we cannot access y. Why? The reason is because f is of type father, so I can access only the superclass properties. My visibility is only superclass. So therefore, I can access only X over here. Whereas the subclass properties, I cannot access. I cannot access Y. Why? Because it is subclass property here. Got it? So these are the few points which you are supposed to be, you're supposed to understand. Clear? Done. So this upcasting, here I have done it in a single line. But we can do it in two lines as well. How, sir? I'll tell you. See, now I create an object. See, new sun. I create an object of subclass and store it into a reference which is of type subclass only. So S is storing the subclass object. Okay, S is storing the subclass object and the reference type is sun only. So S is nothing but the subclass object. I am storing it into a reference of type superclass. So this is also upcasting. How? See, subclass object. Okay, that subclass object is getting stored into S here, and that is of type sun only. So S is nothing but the subclass object, and that subclass object is getting stored into a reference F which is of type father. So superclass reference, subclass object. This is directly and this is indirectly, but both are nothing but upcasting here. Both means upcasting. Got the clarity over here? Okay, so this is called as upcasting. Similarly, okay, once I have done upcasting, we need to always downcast it as well. Okay, upcasting is from first floor we are going to second floor. Downcasting means from second floor, we are coming back to first floor here. So this is called as downcasting. So how shall you do downcasting over here? See, it's very simple. The upcasted reference, right? The upcasted reference, you are trying to convert back to subclass type reference here. So F is of type father, superclass. That is the upcasted reference. The upcasted reference you are converting to subclass type reference here. From father, I am coming back to son here. So downcasting can be done explicitly, and that too after upcasting only. So how will I do it explicitly over here? This F, I am trying to convert it to son. Okay, the type of father, I am trying to convert it into son. So I have to do it explicitly. How will I do it explicitly? To which type am I trying to convert? Son. I have to write son over here. But son F will become like declaration. So I have to add it within parenthesis. So this is called as downcasting here. So with the subclass reference, I can access X also and I can access Y also. S is of type son. I can access both superclass property and subclass property. There is no restrictions at all. Okay. So this is what we are supposed to understand, a few things which we are supposed to do here, right? So this is all about the data here. Okay. So I hope you just got the basic idea here. Okay, not completely, just basic. That's more than sufficient for me. It's not that you have to understand completely in a single go, which you'll not understand. Okay, so in simple terms here, if you go back to my notes here, so there are 4 plus 4, 8 points. You have to remember those 8 points here. See, what is upcasting here? Upcasting means we are creating an object of subclass and storing its address into a reference of type superclass. Meaning, superclass reference, subclass object. That is called as upcasting. And once we have upcasted, my visibility is only superclass properties. So therefore, I can access only superclass properties, not the subclass properties. Okay. And in order to achieve upcasting, easy relationship is mandatory. Okay. Meaning inheritance is mandatory. Without inheritance, I cannot achieve upcasting. And upcasting will always happen implicitly. Automatically, I have to just follow the basic syntax here and it will be done. Okay, this is all about upcasting. And what is downcasting here? So once I have downcasted, see, so the process of converting the upcasted reference back to subclass type reference. Okay, so we are converting from upcasted reference to downcasted, meaning the subclass type reference. That is called as downcasting. Once I had downcasted, okay, my visibility is both superclass and subclass properties. So I can access them both. And downcasting should be done explicitly and that too after upcasting. Without upcasting, I cannot do downcasting. So first, from first floor, you go to second floor. From second floor, you come back again to first floor here. So for achieving downcasting, upcasting is mandatory. Got it? Okay. So these are the few things which we are supposed to understand when it comes to upcasting. So I hope you just got the basic idea, right? So now it's very simple, guys. Okay. See here, let me tell you a few things here. Okay. Now, we are aware of something called as widening. No, see, when I tell int x equals to 5, what did you understand, sir? X is pointing to a value that is nothing but 5, right? Now, what I'll try to do here is x is storing 5, right? So x, I want to convert it into double and then store it into y here. So x is nothing but 5. That 5 is getting converted to double and getting stored into y here. So the y value will be 5.0. Why? We're converting int to double, small to big. That is nothing but widening here. Correct. The value of x is 5. So therefore 5 is getting converted to double here. See? So this x is storing 5. This x only, the value of x only, I'm trying to convert to double and store it into y. So this is called as implicit casting, that is widening. Whereas, okay, If I have to do it explicitly, see, double x equals to 5.6. So what did you understand, sir? The value x is pointing to, the variable x is pointing to a value called as 5.6. Now, this x, which is of type double, see, x is of type double, this x, I want to convert it into int and then store it into y here. Sir, double to int, big to small, we have to do it explicitly. How will I do it explicitly? To which type am I trying to convert? Int. So when I tell int x, that becomes like declaration. So we have to add it within parenthesis. Now y will get store only 5. Why? X is 5.6. The integer value for 5.6 is 5 here. So this is nothing but explicit casting. That is nothing but narrowing. Got the clarity here? So implicit is similar to upcasting and explicit is something similar to downcasting. And for upcasting, easier relationship is mandatory, and for downcasting, upcasting is mandatory. With the upcasted reference, oh, I'm so sorry. Okay, so with the upcasted reference, only superclass properties. With the downcasted reference, both superclass and subclass properties, both we can access it. So this is how we are supposed to understand what is upcasting and downcasting. Okay, for the people who know it already, might be revision for you all, but probably today and tomorrow, once we are done, we will be jumping into abstract interface and abstraction, which are not you. I mean, with the topics which you are not aware of. Probably upcasting and downcasting, you're aware of it. Okay, but still, I want you all to attend and gain the knowledge. But probably after tomorrow's session, okay, so I'll be doing something called as abstract interface abstraction, wherein it would be a new topic for you all, okay, wherein you can all understand easily. Okay, so this is all about the entire process of understanding upcasting and downcasting. So now, can we take one more example so that you'll all get the complete clarity about whatever we learned here? Absolutely. Okay, now closely observe. Okay, now you have to concentrate. Okay, so I have a couple of classes. Okay, I'll have a couple of classes. Okay, so this is one class and this is another. Okay, so there are two classes over here, guys. Imagine this class name is vehicle and this class name is car. So there are two classes, vehicle class and car class, and there is a relationship between them. Is a relationship meaning extends. Okay, is a relationship means extends here, right? So vehicle is having a property A, which is storing the data called as 10, and car is storing the value called as 20. Okay, now, so this is all about it. There is vehicle class, there is car class, and there is a relationship between them. Okay, now, vehicle is storing A equals to 10, and car is storing B equals to 20. This is all about it. Okay, now, what am I supposed to do here? I need to achieve upcasting. I need to achieve upcasting. Upcasting can be done in two ways. That is either directly or indirectly here. Okay. So for the people who have slight difficulties in understanding the first example, concentrate. What is upcasting? Upcasting is nothing but creating an object of subclass, creating an object of subclass and storing its address into a reference which is of type superclass here. This is called as upcasting. What is upcasting? I repeat, creating an object of subclass and storing its address into a reference which is of type superclass. In other words, superclass reference. See, superclass reference subclass object. That is called as upcasting. And upcasting can be done only in case of is a relationship. Is there is a relationship between them? Yes. So I can easily achieve upcasting. And upcasting will always happen implicitly. Why? Because it is subclass to superclass. So it will always happen implicitly. So once I have upcasted, V is of type vehicle. My visibility is only vehicle class properties. My visibility is only superclass properties. Therefore, with the reference V, I can access only A, but B I cannot access. Why? A is superclass member, B is subclass member. V is of type vehicle, only superclass members I can access. Subclass members I cannot access. So this is all about upcasting. But this can also be done in a different way. How? See, simple. Creating an object of subclass and storing its address into a reference of type car only. So this is subclass object that is getting stored into C, and that is of type car only. So C is storing the subclass object. Okay, now C is storing the subclass object. C is nothing but the subclass object that is getting stored into a reference V which is of type vehicle. Even this is upcasting. See, this is upcasting. C is of type car, okay, subclass object that is getting stored into superclass reference. So there are two ways of doing it, but based on the project scenario, we are going to choose one. Okay, superclass reference, subclass object. C is storing the subclass object. So this is directly and this is indirectly. Got it? Done. So now from subclass, I have gone to superclass here. That is nothing but upcasting is done successfully. Now I have to come back as well. I have to come back to this data. This is nothing but downcasting. So how will I do downcasting here? Very simple. Okay, I have to achieve downcasting. So first of all, downcasting can be done only after upcasting. Have I upcasted? Okay, just a moment, guys. 1 minute. 1 minute. Yeah, perfect. Yeah, just a moment, guys. I just had some important call. Right. So now this is downcasting. So what is downcasting over here? So only after upcasting we can do downcasting. So the upcasted reference, see, the upcasted reference, we are trying to convert back to subclass type reference here. So upcasting is from subclass to superclass, car to vehicle. Downcasting is vehicle to car, superclass to subclass. So V is of type vehicle. I am trying to convert back to car C. That is from superclass reference to subclass type reference here. But downcasting should always be done explicitly. How will we do it explicitly? Sir, to which type are you trying to convert, sir? Car. So we are supposed to write car over here. Then open parenthesis, close. Why? Because we are casting, not declaring, right? So once we have downcasted, okay, with the reference C, I can access both superclass property and subclass property. I can access both the properties in a beautiful manner. So this is all about upcasting and downcasting here. Okay, now. So who will happen implicitly, guys? Upcasting. Who will happen explicitly? Downcasting. Implicit upcasting, explicit downcasting, right? For upcasting, what is mandatory? Is a relationship is mandatory. For downcasting, what is mandatory? Upcasting is mandatory. For achieving downcasting, upcasting is mandatory. For achieving upcasting, inheritance is mandatory. Got it? With the upcasted reference, with the superclass reference, my visibility is only superclass properties. So I can access only superclass members. But with the downcasted reference or the subclass reference, I can access both superclass members and the subclass members. This is all about upcasting and downcasting, right? Upcasting means superclass reference, subclass object. Downcasting meaning the superclass reference, we are converting back to subclass type reference. So this is all about upcasting and downcasting, right? So I hope you all got the basic idea about what is upcasting and downcasting. Now you'll have one important doubt. Sir, what the hell, sir? Why are we doing it, sir? Okay, I will answer. Patience, patience, patience. Okay, but let me do it practically once so that you'll all be able to relate it easily. Okay, so I'll go back over here. So we already have a package called as typecast, project called as typecasting. We also had a package called as primitive casting. So in today's session, it's non-primitive. Control N, I create a package and the package name is non-primitive. Okay, I'll just write it as non-primitive. Okay, under that, let me create a class here. Shortcut key, Control N. The class name is father. I'll create a class called as father here. Okay, now great. So now over here, what did we understand? It's very simple program. Package non-primitive meaning we have a folder called as non-primitive and father.java is present into a folder called as non-primitive. Class is a blueprint of an object or it's a platform to store states and behaviors of an object and the access specifier is public so that the class can be accessed by everyone, right? And then there is a variable. Int is the data type, okay? A variable name is age and the age of the father is 45, okay? So what did you understand here? There is a father class and he has a data member called as age initialized to 45. Clear? Now, Control N, I will create one more class over here. So I'll create a class name as son. So there are two classes over here, son class and father class. Now, son is also having a property called as name, which is initialized to. I will initialize to Dinga. The name of the son is Dinga and the age of the father is 45. Now, I need to achieve is a relationship between them. That is nothing but inheritance. So, how will I achieve? Extends. I am supposed to make use of extends and the class name is father. Son extends father. So, what did we understand here? So, father class is having a variable called as age and we are initializing that age. We are inheriting that class by son here. Now, I'll have one more class called as test. Okay, so now it's time for us to understand the major concept over here. Okay, so now guys, we are supposed to understand what is upcasting and downcasting. So closely observe over here, guys. I am supposed to do upcasting over here. Okay, so now look here. What is upcasting, sir? Creating an object of subclass. See, I have created an object of subclass and storing its address into a reference, which is of type superclass. In simple terms, superclass reference subclass object is called as upcasting, or creating an object of subclass, storing its address into a reference, which is of type superclass. Okay. So now upcasting will always happen implicitly. So I have to just follow the syntax here and that casting will be done implicitly. Without inheritance, can I achieve upcasting? See, it will throw me an error. Why? There is no easy relationship now. Father is independent, son is independent. No easy relationship possible. So therefore, it's mandatory that I will have easy relationship. Got it? So I made sure that you'll all understand the content. Now, if I have upcasted, see, I can access only superclass property, whereas f dot name. So if I write f dot name, it will give a huge error here. The reason is because, okay, with the upcasted reference, we can access only superclass properties, not the subclass property. So it gives me an error over here. Got it? So f dot name cannot be accessed. Okay, f dot name will give error. Okay, I'll just write f dot name will give error over here. Understood? This is all about upcasting. Now, how am I supposed to do downcasting here? Downcasting can be done in different way. How is it? Sir, the upcasted reference we are trying to convert back to subclass type reference here. So superclass reference to subclass type reference here. So we have to always do it explicitly. So how shall we do it explicitly here? So this f is of type father. I need to write the type to which I'm trying to convert. I'm trying to convert it to son, but I have to write it within parenthesis over here. Okay, so this is all about the basic content over here. Okay, further clarity here. So downcasting will always happen explicitly, and that too after upcasting. Okay, we cannot do it directly over here. Got it? So this is all about the basic content which we are supposed to the data here. Okay, I hope you all got the basic idea about the content here. Okay, so now with the subclass reference, I can access both superclass property. See, I can access the superclass property and subclass property. See, h dot name here. See, I can access both here. So this is nothing but downcasting over here. Okay, what is this? This is nothing but downcasting. This is all which we are supposed to understand here. So now when I execute it, will I get the content here? Huh, absolutely. I should be able to get the expected output. Did I get the expected output over here as 45, yeah, 45 and 45 dinga. Did I get the output? Absolutely. So this is all about upcasting, guys. With upcasted reference, only superclass properties. Subclass properties cannot be accessed. With the downcasted reference, with the subclass reference, both superclass and subclass properties. Okay, upcasting implicitly, downcasting explicitly. For achieving upcasting, inheritance mandatory. For downcasting, upcasting mandatory. This is all about the actual content here. Got it? So we know what is the upcasting definition and what is the downcasting definition, don't we? Okay. So this is all about the basic content of the data here. So this is what we are supposed to understand here. Got it? Perfect. So we are done with, okay, the basic things which we are supposed to understand here. Okay. So just observe at the code. Okay. I'm supposed to do one more example. Okay. So have patience for it. But if you have any confusions, you can let me know. Okay, so there's one common question which I will always come across. Sir, why the hell do we require upcasting? Okay, that's a common question. I shall answer in probably another 10 to 15 minutes. Okay, right. So now there's one more question. Sir, upcasting can be done in one more way, no, sir? How is it, sir? Simple. See, new son. Okay, when I tell new son, it's the subclass object. I am storing it into a reference, okay, which is of type X and that is of type Sun only. I've taken S already, no, so that's the reason I'm not talking. So, new Sun is nothing but the X. It is stored. See, new Sun is nothing but the subclass object that is stored into X, which is of type Sun only. So that X, which is of type Sun, I am trying to convert it back to, okay, see here, X is of type Sun. I'm trying to convert it back to Y, which is of type father here. See, this is also upcasting, actually speaking. See, creating an object of subclass and storing its reference into X. X is nothing but the subclass object. The subclass object is getting stored into a reference Y, which is of type superclass. So even this can also be followed. So if you don't like this data here, you can actually write it as F, S and F. So I'll just comment this entire data here. See, now will it work here? Yes, see, creating an object of subclass and storing it into a reference called as S, which is of type Sun only, subclass object. That subclass object is getting stored into superclass reference. So even this is nothing but upcasting here. So you can do it however you wish to. It's not that you have to do it in this way only, but it's all about understanding way here. Okay, this is all about it. Okay, I hope you all got the clarity of this data here. Okay, great guys. Okay, so we are actually done with what is upcasting and downcasting here. Okay, so I'll give you a couple of more examples here so that you'll all understand it in a beautiful manner here. Okay, so yeah, one more example so that you'll have better clarity of this entire topic. Okay, so let's go ahead with one more example, quick example. Okay, then we'll try to talk about the rest of the things here. Okay, so yes, now let me create a couple of classes here. Okay, Control N. I will create a class, and the class name is vehicle. Okay, and the class name is vehicle here. Okay, in this vehicle class, I will have a property string brand equals to, I will just write it as BMW. Okay, I'll just write it as BMW, right? So vehicle is a class and it has a data member which is like brand initialized to BMW. And I'll also have a method. Void is the return type. Start is the method name. Open parenthesis close, and just I'll write it as vehicle. Okay, vehicle starter. I'm just writing it as a normal data as vehicle starter. I hope we all got the clarity about what is happening in this respective class here, right? So we just have a normal class called as vehicle. It has a couple of members, right? One data member, one member function, meaning one variable, one method. That's it, right? Now I will have one more class, and that class name is car class. What is that class name here? That is nothing but car class here. Okay. Now I need to achieve easy relationship. That is nothing but inheritance here. How will I achieve inheritance? Extends vehicle. Okay, extends vehicle. Okay, so now I tell extends vehicle, meaning we have successfully achieved upcasting over here. Sorry, we have just achieved easy relationship, that is inheritance. Now here car class also will have a couple of variables, that is string fuel equals to petrol here. Okay, and I'll also have a method void stop method. Okay, I'll just give the implementation as car stopped here. Okay, so I've just given the basic implementation, guys, nothing. Okay, so this is a simple example for a single level inheritance, right? So we had once vehicle class, we have another class called as car, and there is easy relationship established between them, right? Now I'll have a class called as demo, wherein I'm just going to explain the program, that is upcasting and downcasting. I'm just going to explain it over here. Okay, so now here guys, I'm just going to have a main method. Okay, now guys, concentrate one last time. Okay, this is all about it. This is the last example for upcasting and downcasting, but we'll be doing a lot of examples which is relatable. Okay, so concentrate. Okay, so if you're sleeping, wake up. Okay, slap yourself, wake up and concentrate. Okay, see here, what is upcasting? Creating an object of subclass. Okay, creating an object of subclass and storing its address into a reference which is of type superclass here. See, creating an object of subclass, storing its address into a reference which is of type superclass. Superclass reference, subclass object. This is all about upcasting. And upcasting will happen implicitly and inheritance is mandatory. Now, with the upcasted reference, we can access only superclass property. See, only brand is visible. But if I just write v.fuel, it will give a huge error. Why? Sir, V is of type vehicle and I can access only vehicle, that is superclass property, subclass property I cannot access. Therefore, fuel we cannot access. Similarly, we can access only start method, but if I write stop method, it will give an error. Why? Sir, stop method is a subclass member. You cannot access it with the help of superclass reference. It will give an error, right? So you have to be very, very smart enough. So this is upcasting. Once we have upcasted, only superclass properties. Now how will I downcast it? V is of type superclass, that I'm trying to convert it to car here. But downcasting should always happen explicitly. So I have to add a cast here. Okay, downcasting should always happen explicitly, and that too after upcasting. Once we have downcasted, we can access the superclass property as well as subclass property. See, I can access everything without any problems here. Okay, without any problems, I can access both the properties here. This is the difference between upcasting and downcasting. So when I executed, did I actually get the output here? Yes, we got the output. Got it, right? So this is all about upcasting and downcasting, right? So observe at the program for a couple of minutes. Okay, so I'll tell you the what are the advantages, everything now. Okay, so we're done with a couple of examples, and I hope you all got the basic level of understanding. But what is the major reason we are trying to do it? Okay, this is what we are supposed to know. Okay, I'll tell you now. Okay, perfect. Correct. So this is all about upcasting and downcasting, guys. So we saw what is non-primitive casting. It's simple. Okay, class type casting. We're trying to convert one type of class into another. There are two types, upcasting and downcasting. So we have seen many times here. I've repeated this several times. Okay, the only reason being I want you all to understand like a pro. Okay, now guys, sir, we understood upcasting, sir. We understood downcasting, sir. But why the hell are you doing it, sir? Okay, I will tell you it. Okay, now imagine, guys, imagine you have a method. Okay, now it's important for you all to understand something. Okay, you have a method called as display. Okay, open parenthesis, close, open curly braces, close. Okay, now to the display method, okay, to the display method, you are passing some kind of data. Just a moment here. I will tell you, what am I trying to explain? I will explain it beautifully. See here. This is a display method, and I'm calling the display method by passing 10. So when this 10 is going, okay, when then 10 is going over here, I will store it into a variable a, which is of type int. Why? Sir, you're passing 10, sir. That 10 will get stored into a variable a and the type should be int, sir. Very good. Now, if I write, okay, if I write 10.5, what did you understand? Sir, you are passing a decimal value. So that is getting stored into a variable a, sir, and the type should be double, sir. Why? Because we are passing 10.5. So based on the value I am passing, I will decide my data type here. Very good. Similarly, I will pass Java. Sir, Java is a set of characters, sir. It's a string. I am passing here. This Java will get stored into A and the data type will be string here. So what did you understand over here? Sir, based on the value I am passing, I have to decide my data type over here. If it is int, I can only pass 10, 10.5 and Java are not allowed. If I write it as double, only this is allowed, these two are not allowed. If I write it as string, only this is allowed and these two are not allowed. Got the clarity now? So based on the data type over here, I have to restrict what I'm trying to pass here. Got it? Similarly, we have a concept called as, okay, similarly, we have a concept. Okay, what is that concept? I'll tell you. Okay, we have a concept called as specialization. Okay, specialization and generalization. Okay, specialization and generalization. This is the major advantage about upcasting here. I will tell you what is it. Okay, now imagine, guys, I have a beautiful class. Okay, and that class name is something. Okay, I'll tell you. Okay, so that class name is something, and I have a few things here: developer, HR, tester. Okay, now see, guys, I have a class called as employee. Okay, and this employee class has three subclasses. One is developer class, and one is HR class, and other one is tester class. Okay, employee is the superclass, developer, HR, and tester are the subclasses here. Do you all agree with this process, guys? Developer is a type of employee, HR is a type of employee, tester is also a type of employee. Okay, now, so now, guys, we are supposed to understand specialization. What is specialization? See here, when I write tester T, I can store only tester object. Okay, when I write tester T here, when I write tester T, I can store only tester object. That is called as specialization. Only specific types of objects I am able to store here. If I write it as HRR, I can store only HR objects. That is called as specialization. R is of type HR. I can store only HR object. Okay. Similarly, tester developer. See, if I write it as developer D, I can store only developer object. So this is called as specialization. D is of type developer, only developer object. So these three are an example for specialization. Only specific types of objects I can store. Now, generalization means, okay, generalization means, see now, if I write the reference type as employee E, okay, E is of type employee. So E is of type employee, no, I can store the developer object also, okay, the developer object also, HR object also, and tester object also. Okay, so this is called as generalization. What is this called as? Generalization. See, what is upcasting, guys? Creating an object of subclass, store it into a reference E, which is of type superclass. Create an object of subclass, store it into a reference E, which is of type superclass. Create an object of subclass, store it into a reference E, which is of type superclass. So into a single reference type, okay, which is of type employee, I can store developer object, HR object, tester object. So that is called as generalization. But if I write it as tester T, only tester object, HRR, only HR object, developer D, only developer object. Got it? So this is called as specialization and generalization. But one more way of understanding. Okay. Now imagine I have a method called as display. Okay. I have a method called as display. Open curly braces, close. Now I am calling the display method. See, display of. Okay, now I am calling what? Display method. Okay, wait for it, wait for it. So now guys, you are supposed to be very, very smart enough. Now, I am passing an object of developer. I'm not passing 10 or 20. I am passing an object of developer that will get stored into a reference D, which is of type developer only. That is called as specialization. If I'm passing an object of developer, I'm storing into a reference D, which is of type developer only. But if I am passing an object of tester, okay, if I'm passing an object of tester, that will get stored into reference T, which is of the type tester here. That is again specialization. If I'm passing new HR object, that will get stored into a reference H, which is of type HR here. So what is this? This is specialization. If it is developer D, I can pass only developer object, tester object cannot be allowed, HR object cannot be allowed. But if it is tester T, I can allow only tester object, developer object and HR object not allowed. If it is HRH, okay, I can pass only HR object, but tester object and developer object cannot be passed. Got it? So this is called as specialization. Developer D, only developer object. Tester T, only tester object. HRH, only HR objects can be passed to that particular method. But imagine here, I have to create a generic method in such a way, I should be able to pass all the objects. Okay, now, not only developer, not only tester, not only HR, I should be able to pass all the objects. Sir, what will you do, sir? Simple. I will just create a method called as display and the reference type, see, I am calling the display method here. Display of. Display of. Imagine I'm trying to call the method thrice. Okay. and I am passing different types of objects. See, here I am passing developer object. Okay, now here I am passing tester object. Okay, now and here I am passing HR object. So now I have to create a reference type in such a way even developer object should be allowed, tester object should be allowed, and HR object should be allowed. So here if I write it as E, what will be the reference type or data type over here? Can you think and tell me here? What will be the reference type, guys? Think and tell me. See, I should be able to pass this developer object also. I should be able to pass this tester object also, and I should be able to pass the HR object also. All the objects should be stored in a single reference type. So what will be the data type over here? It's simple, sir. Write it as employee. If you write it as employee, the superclass type, I can pass all the subclass objects. See, creating an object of subclass and storing it into a reference of type superclass. That is called as upcasting. So the major advantage of upcasting is generalization, meaning into a single reference type, I can pass different types of objects here. Got it? So this is the major advantage, and we have many more advantages which I shall be doing it in the coming session. But I hope you all got the basic level of understanding here. This is all I wanted. Okay. Similarly, okay, concentrate everyone. I have a method called as eat. Okay, now I have a method called as what? Eat here. So now to the eat method, okay, I will be passing a couple of objects here. Okay, now you have to just observe it. If I am passing, okay, eat method, if I am passing dosa object, okay, if I'm passing dosa object, I'm passing dosa object that will get stored into D, which is of type dosa here. If I am passing idli object, okay, if I'm passing idli object, I will store it into a reference I, which is of type idli here. Okay, now, if I am passing what more vada object, no? New vada object here. All South Indian dishes, guys. If you don't like it, you can write whatever you want. Okay. So if I'm passing vada object over here, I will store it into a reference V, which is of type vada here. Okay. So now if it is, okay, if it is dosa D, only dosa object allowed. Idli I, only idli object allowed. If it is vada V here, only vada object allowed. Got it? So this is specialization. Only specific types of objects we can pass. Okay. But if I want to allow a generic, to a single method, I should be able to allow all the different types of methods. So now what I'll do, I had to use some common sense here. I'll tell, okay, imagine what if all these classes had a common superclass. Okay, meaning food is the superclass and dosa is inheriting food, idli is inheriting food. Imagine idli is inheriting food and vada is inheriting food. So this is the superclass and these are all the subclass. So if I'm supposed to pass dosa object also, idli object also, okay, and here if I want to pass vada object also, if I'm passing vada object, idli object, dosa object to a single reference type, what should be the data type over here and what should be the reference name? You give whatever, sir, but the data type I will write as food here. So if I write food F here, I can pass dosa object, idli object, vada object to a single reference type. I can pass different types of object, dosa object, idli object, vada object. I can pass all those objects into a single reference type. This is nothing but generalization. Okay. So this is the major advantage of upcasting over here. Got it? This is all about the basic content which we are supposed to have here. Okay. So this is all about upcasting and downcasting. I hope you all got the basic level of understanding over here. Got it? So this is what we are supposed to understand, guys. Okay, it's not a tricky concept, but it's a very simple topic which we are supposed to understand. Right? Perfect. So what have we discussed in today's session over here? So we just saw what is upcasting and downcasting. It's very simple. Okay. Imagine you answer yourself. Simple. Okay, don't look at anything. Okay, okay, just have a look at this and tell me who will happen implicitly. Obviously, upcasting. Who will happen explicitly? Downcasting. Okay, inheritance is mandatory for upcasting. Upcasting is mandatory for downcasting. Once I have upcasted, I can access only superclass properties. If I have downcasted, both superclass and subclass properties. Got the clarity? And what is upcasting definition? Creating an object of subclass and storing it into a reference which is of type superclass here. Okay, and downcasting is nothing but the upcasted reference, the superclass reference, we are trying to convert back to subclass type. Okay, so this is all about upcasting and downcasting here. Got it? So this is all about it. Okay, so anyone having any questions in today's session? I have a couple of announcements. Wait for it. Don't run away. Okay, wait for it. But as of now, anyone having any questions over here? Okay. Hey, answer. Everyone sleeping here? No, right? Any questions here? I have one question. I'll read out. Okay. So I'll send it to everyone. You can also, just read out. Uh, the parent class object cannot access child class object unless downcasted. So we have to sort of specialize again to access the child class properties. Absolutely. Okay. So if you are passing, okay, see, if you are passing dosa object over here, that is stored into superclass reference. So you can access only food properties. Later you need to specialize over here. That is the reason we have downcasting again. So this is upcasting, right? Dosa object got stored into food. That is upcasting. But later, once I have upcasted, only superclass properties. Later I need to downcast over here, specialize. That is my next topic. Okay, that I'll be doing it tomorrow, because once we downcast it, we come across an exception called as class cast. We need to avoid it. That's the reason. Okay, but what were you told? Yes, first generalization, then specialization. We have to come across both the concepts. Okay, perfect. Any confusion by anyone, guys? Any confusions, anyone? You want me to repeat something? Guys, if you don't respond, I'm just gonna kill you all directly. Any questions, anyone? Right, very good, very good. Okay, so first of all, okay, a few of them will not be aware of my name also, because yeah, I'll just brief out, okay, a few things about the session and all those. Okay, yeah, we have space over here. We'll try to do it here. Okay, great. Guys, so 61 and 62 batch, you'll be aware of Keshav sir, I believe, right? So Keshav sir, so he also takes Java and he's the one who manages JSpiders, okay? And my name is Uday, okay? I also train on Java and Python, both the technologies, okay? And I also work in Test Yantra, okay? So these are the few things about me here, okay? So this is all about it. So, and what I do here is on daily basis, I send the notes, probably most of the time, notes and the programs of all the topics which we have discussed, okay, with the screenshots, okay. So this I'll be forwarding it from today's session as well. Probably upcasting and downcasting, you would have understood it long back, because Keshav sir would have done it, okay. If not here, okay, probably today, you should have understood, because it's like a couple of times we have done it, okay. You should have understood. So tomorrow it's the continuation of upcasting and downcasting. That is, we have something called as class cast exception, instance of, okay, all this. So we shall try to cover this two things in tomorrow's session, and then jump into abstract, interface, abstraction. So if you are aware of those concepts here, it's good. If not here, attend my session, get to know the flow, and so that we can complete Java in a very good way, and you'll all be strong enough to clear any interviews. Clear? Perfect. Great. Okay, so we're pretty much done with the session, guys. Okay, so tomorrow I'll be completing upcasting and downcasting for you all. So, but the only request I have is, okay, you need to practice it. Okay, practice well. And the class is at 9:30. Okay, not at 9 o'clock. The class will always start at 9:30. My session. Okay, I don't want to do it at 9 o'clock, because majority of you are attending apti classes, I believe. I'm not sure. Okay, but we'll do it at 9:30, because I generally take it at 9:30. So we'll do it at 9:30 only. Okay, So today it's just the basic flow. I hope you'd have got the clarity about it. Okay. Tomorrow we'll meet up at 9:30. Okay. So great guys. Okay. So we shall wind up a session for today and catch up tomorrow at 9:30. Okay. So notes link I'll forward it to you in the WhatsApp group itself. Okay. So you can download it there. Okay. So great guys. Okay. So we'll wind up a session for today and catch up tomorrow at 9:30. Okay. So thank you all. Take care. Bye bye. Have a nice day.